Hello everyone, welcome to my Physics 2211 Lab 1 Constant Velocity. So the purpose of this lab is to observe and analyze the motion of an object moving at a constant speed in one dimension, and to compare these observations to a computational model based on physics principles. By recording a video of motion, tracking the object's position over time using Tracker, and constructing a VPython model, we learn to apply Newton's second law to predict motion. We also practice data analysis and validating a computational model against real-world observations. This lab emphasizes the understanding the relationship between net force, velocity, and position. The main physics principles explored in this lab include Newton's second law, which states that net force acting on an object is equal to the product of its mass and acceleration. It also explores constant velocity motion, as well as Newton's first law, which states that an object will remain at rest or in uniform motion unless acted on by a net external force. Here are the models and formulas used. Some formulas we used include velocity update, position update, average velocity, and Newton's second law formula. The reasoning for these models and assumptions is that using a point mass model simplifies the system and isolates motion along one axis. Assuming zero net force also matches the observed constant velocity, which is consistent with Newton's first and second laws. In addition, comparing the computational model to the tracker data validates the assumptions and demonstrates that the model accurately predicts real-world motion. Here are the experimental details used. The initial position of the marker was set at 2 inches at the start of the video, and it moved in a straight line at a nearly constant speed. The system is consisted of the marker rolling along the flat table with a ruler placed alongside to provide a known length for calibration. The surroundings include the table, air, and gravity. And the video was captured with the camera stationary perpendicular to the direction of the motion. Here are the coding details used. We implemented in VPython GlowScript to simulate the motion of a marker along a straight line. The main goal of the code was to predict the position of the marker over time based on constant velocity motion using the momentum principle. Here are also the key elements of the code, which include the object definition, initial conditions, calculation loop, and plotting and output. Here are the GlowScript initial conditions, and this is the tracker results. As you can see, the X and T graph shows a constant velocity line. Here is our experimental procedure. We set up first, we placed a ruler along a flat table and set a camera perpendicular to the table. Then we recorded the motion. Next, we calibrated in Tracker, and we opened the video in Tracker, used the ruler as a calibration stick, and placed the first point on the marker. We tracked the motion by moving frame by frame and clicking the marker in each frame to record its position. Finally, we analyzed the data by exporting the time and position data, calculating velocity, and comparing the observed motion to the VPython computational model. Here is the results of the computational model. And here is the computational versus experimental line graph. As you can see, the slopes are almost equal, however, they are placed a bit far apart from each other. The similarities are that both the lines are straight, showing constant velocity, and they're identical, confirming that the model accurately predicts the marker speed. The differences are that they are vertically offset due to different starting positions, and this could be due to minor deviations in tracker data, as well as human error. Possible sources of error include tracking error, calibration error, environmental factors such as small bumps on the table or uneven surface, as well as the camera angle and slight deviation from being perfectly perpendicular. What would happen if we change the x and minus x axes? then the graph would be mirrored along the vertical axis and the slope magnitude would stay the same, but the sign of the velocity would change. Physically, the motion would still be the same, but in the opposite direction. What does this mean? The net force along the horizontal direction would still be zero. Even if multiple forces act, they still sum to zero during the constant velocity motion. Thank you.